There are three common tricks for writing down the parameterization of a curve that I'd like to show you. The first one is to parameterize a line that goes between 2 points. So let's parameterize the line that goes from this point, -2, 4, to the point 3, 1. The idea here is we have two x coordinates, -2 and 3. These are our x coordinates. And our y coordinates are 4 and 1. And the idea is what we're going to do is use our parameter to sort of start with these first coordinates being on, and then as t increases, so that's going to be at t equals 0, and then as t increases to 1, we're going to turn on the second pair of coordinates and turn off the first pair of coordinates. So it's actually easier to start with the second pair of coordinates. So we need to come up with some way of messing with these coordinates so that when t is 0, they're off, and when t is 1, we just get 3 for x and 1 for y. And we can make that happen by multiplying both of these by t. So now when t is 0, this second pair of coordinates, 3 and 1, disappear because they're being multiplied by t. But when t is 1, you get 3 times 1, which is 3, and 1 times 1, which is 1. So this has the effect of turning these coordinates off at first and then on when t is 1. So now we need to come up with a similar idea for messing with our first pair of coordinates, -2 and 4. And using the same idea, we need to multiply both of these by 1 when t is 0, and by 0 when t is 1. And if you think about it a little bit, what you need to multiply by is 1 minus t. So just a quick mental check. When t is 0, we're going to get -2 times 1 and 4 times 1. When t is 1, both of these chunks in parentheses are just 0, and you get -2 times 0 and 4 times 0. So this does turn this first pair of coordinates on at first and then off when t gets to 1. Okay, so we've turned all of these on and off at the correct times. Now we just need to combine the old coordinates and the new coordinates, so let's just add them. All right, so this, we think anyway, that this is the right this is a parameterization that will do what we need. Let's just do a quick check by plugging in t equals 0. When t equals 0, x is -2 times 1 minus 0 plus 3 times 0. And that is -2, which is what it was supposed to be. And y is 4 times 1 minus 0 plus 1 times 0, and that's 4. So when t is 0, we're at our initial point. And then when t is 1, x is -2 times 1 minus 1 plus 3 times 1. This 1 minus 1 makes this first piece go away, and we just get 3. And for y, the same sort of thing. 4 times 1 minus 1 plus 1 times 1, that's 1. And so when t is 1, we're at our ending point. So this trick, sort of using t's to blend the beginning and ending coordinates, will really work for any 2 points. There was nothing that we did here that was special about for these 2 points. So if you have any 2 points, you can easily parameterize the line segment between them just by blending them in this way. Okay, the second common parameterization is parameterizing a circle, especially a circle of a given radius. So if you think back to earlier, right, we have this situation where if you have an x coordinate and a y coordinate and a radius and an angle, then sine theta was y over the radius, cosine theta was x over the radius. And this means that if you clear the denominators, y is r sine theta and x is r cosine theta. Well, if you have a particular radius in mind, and we do, 4, then this looks like a pair of parametric equations, 4 sine theta for our y equation and 4 cosine theta for our x equation. So you can use it. The only reason this might not look like a parametric equation like we're used to is because we have theta instead of t. But, you know, it doesn't matter what the parameter is called. If you want to call it theta, you can. Or if you like to call it t, you could just replace the theta with t. Now we have a parametric equation for tracing out this circle. And this trick is always going to work. So if you want to parameterize a circle with radius r, you can use x equals r cosine t and y equals r sine t. Of course, this parameterization starts at a certain spot, the right-hand spot, and goes in a certain direction, counterclockwise, at a particular speed. If you want a different radius, a different speed, or if you want to start at a different place, you'd have to change this parameterization. All right, the third example of a common parameterization is what if you want to parameterize a polar graph? So remember, the polar graph of an equation like this, so in general we could write r equals f of theta. In general, a polar graph looks like f of theta, comma theta, and this is in polar coordinates. But remember, to switch to rectangular coordinates, x is just r cosine theta, and y is r sine theta. But our r value is right here. It's f of theta. So we'd have f of theta times cosine theta for x. And for y, we'd have r, which is f of theta, times sine theta. Of course, for this particular example, f is right here, 2 minus 2 cosine theta. So this would be 2 minus 2 cosine theta times cosine theta. And for y, we'd get 2 minus 2 sine theta, 2 minus 2 cosine theta times sine theta. So these parametric equations would actually trace out the graph, that polar graph. And if you remember, this polar graph turns out to be a cardioid, so something like this. So those are 3 tricks that are commonly used to write down parametric equations for some common situations.